Hello friends. So this problem is about binding a string on a cylinder. So problem says a vertical cylinder of radius r is placed on a horizontal surface. A small disk of mass m is attached to the cylinder by a horizontal thread mb of length L0. One end of which is attached to the cylinder at point B as shown in this figure. So the disk is thrown with an initial velocity v0 so that the thread starts binding over the surface of cylinder. We have to find the time after which the disk will strike the cylinder. So what are the things that is given? So here I have a disk and this disk is attached to cylinder through a string. And the length of a string is given, this is L0, and this is the cylinder, and the radius of cylinder is also given. Let's say this radius is R. And the mass of disk is given, that is M. And this is thrown with a velocity V. So velocity is also given. So what we have to find? We have to find time after which this disk will strike to the cylinder. So how will you do this problem? One thing is, there is no force that is in the direction of velocity. So you see, this is the velocity direction. So there is no force that is acting in the direction of velocity. Only force that is acting on this disk is the force due to the thread, and that is perpendicular to the velocity. This means I can say velocity will remain constant. So V, I can say V will remain constant. So V0, V is basically constant. Because there is no force, so V will not change. Now let us say this has rotated through an amount theta. So this has rotated through an amount theta. So now how this thing will look? So in this case, your string will look something like this. So this has rotated. So now a string will look something like this. So here is the mass. So this is mass m. And let's say this angle is theta. So what will be this length, the curved length? This will be r theta. So this means if this length is r theta, then this length will be how much? This length will be how much? If you remember, the initial length was L0. So I have to, because this part of a string is now on the cylinder. So this length is gone. So now left length is L0 minus R theta. So this is the length that is free. Now let us further consider d theta. So at theta there is very small angle d theta, and for this d theta, this binds further. So if this binds further, what we'll have? You will have something like this. So this is the next situation. This angle will also be d theta, because you can prove this. Angle between line is equals to angle between perpendicular. So this line is perpendicular on this line. So this line is perpendicular on this line, and this line, this one is perpendicular on this line. So angle is d theta. So here also this angle has to be d theta. Now as I said, the v remains constant. So still this velocity is again v. So what will be this distance? So let us say at time t. So at this point we have time t, and at this point we have time t plus dt. So we can say in time dt, this distance will be v dt because velocity is constant. Now this distance we can also find using theta is equals to L by R. So if you remember the formula, theta is equals to L by R, and in this case theta is d theta. So this is d theta, and this is equals to, let's say, L by R is how much? So this is my R, that is L naught minus R theta. So this is my R. So now I can use this L naught minus R theta. L is what? Let's call this L is basically x, this distance, or you can say this distance is x. Let's say this, let's call this v dt, which is x. So x we can find from here, x is nothing but L naught minus R theta d theta. Now we have to find how much time it will take to make that complete turn, so that finally the disc is going to collide with the cylinder. So I will give you 2 minutes of time, and pause this video and try to solve this problem. Okay, so let us see the solution, how you are going to solve this. So everything is given. Now this distance x is basically v dt, and x is nothing but, we know this is L naught minus R theta d theta, and this is v dt. Now we can integrate these two equations. So let's v dt keep this side. So if I integrate v dt, and I have to also integrate this side, L naught minus R theta d theta. Time will be 0 to t, and theta will be 0 to, what will be the limit of final limit of theta? So the length is L naught, and then how many turn it will make? It will make L naught by 2 pi r of turns, and in each turn it will complete an angle of 2 pi radian. So this means the final theta will be L naught by r. So this will be L naught by r. Now you simply integrate this. So this will be Vt is equals to L naught theta minus r theta square by 2, and limit will be 0 to L naught by r. So if you plug the value, this will be L naught times L naught by r minus r by 2, and this is L naught by r whole square. So this will be L naught square r minus, this will be L naught square by 2r. So this is basically L naught square by 2r. So the time taken by this disc to hit the cylinder is basically L naught square by 2vr. So this is the time after which this is going to hit the cylinder. Now question for you. Will this time depend upon mass, that is the mass of disk? And if not, why not this does not depend upon mass of disk? Is this a dynamics problem or this is a kinematics problem? So let us discuss all this in the comment box, and I will see you in the next video. I hope you enjoyed this video, and if you enjoy, please share with your friends and subscribe to my channel. Thank you.